Hi everyone. We're going to talk about interpolation, which is what we do when an activity coefficient is not provided in a table. So in this example, they want to know the activity of the sodium ion in this solution. So I'm going to write the equation for activity. That's just equal to the activity coefficient of sodium times the concentration of sodium. And just as a reminder, I may remind myself that when sodium phosphate dissociates in solution, it produces 3 sodium ions and 1 phosphate for every 1 mole of the salt. So the concentration of sodium is not 0.01, but rather 3 times that. So all we need now is an activity coefficient for sodium. And when we go to use that table with activity coefficients, we need an ionic strength. And we can't assume that the ionic strength is 0.01 because our salt does not have a +1 cation and a -1 anion. It has a +1 cation and a -3 anion. So we have to calculate the ionic strength, which is equal to 1/2. And in this case, it'll be the concentration of sodium times its charge squared plus the concentration of phosphate times its charge squared. So again, the concentration of sodium would be 0.030 molar. 1 squared is just 1. The concentration of phosphate would be 0.010 molar, and its charge squared would be 9. So when I did the arithmetic, I got that the ionic strength was 0.060 molar. So let's see if we can find the activity coefficient at this ionic strength. Oh, and I see sodium, but I don't see an ionic strength of 0.060 molar. So this is where we have to interpolate. And when we interpolate, I like to set up a little chart for myself. I make a column for ionic strength and a column for the activity coefficient, and I pick an ionic strength just below and above the missing ionic strength. So in our case, that would be 0.05. The activity coefficient of sodium at 0.05 is 0.82. Then I write down our missing ionic strength, which is what we have, 0.060, and that's what we want. And then the activity or the ionic strength just above 0.06 would be 0.1 molar, and the activity coefficient for sodium would be 0.775. And then I set up a proportion, and I'm going to call this the known ionic strength interval. The known ionic strength interval, and that's going to be proportional to the change in ionic strength, which will be this difference, and that's going to be equal to the unknown activity coefficient interval. So that'll be this difference here, and I'm going to put that over the entire range of the activity coefficient, or delta. So let's see if we can plug everything into this proportion. So again, the known ionic strength interval is the difference between these two numbers, 0.05 minus 0.06. The entire range of ionic strength, or delta, would be 0.05 minus 0.1. On the other side, the unknown activity coefficient interval will be 0.82 minus what we want, That's the activity coefficient of sodium, and the entire change in activity coefficient, again, this delta would be 0.82 minus 0.775. So you have a little bit of arithmetic to do here, but when you do it, you get that the activity coefficient, the missing activity coefficient, is 0.811. So finally, we can go back to our problem. The activity coefficient of sodium then is going to be that activity coefficient that we just got by interpolating 0.81 with an insignificant 1 times the concentration of sodium, 0.030 molar, and I got an activity of 0.024 molar, which is a little bit different from the concentration of sodium. So there are some homework problems where you have to interpolate. I hope you get some practice interpolating, and thanks for listening.